Welcome back, everybody. Today we got a short lesson on weather maps and weather station models. And hopefully by the end of class you'll understand the saying a picture can say 1,000 words instead of all the words. So weather maps, what can they show? Well, there's all kinds of things that are demonstrated on weather maps, and you've seen this on the 6 o'clock news. But there's also other weather maps out there you can find, especially on the internet. And a lot of these can demonstrate wind speed, wind direction, cloud cover, temperature, dew points, present weather, rainfall or any kind of precipitation, snow, air pressure, and the list goes on and on and on. It's kind of cool nowadays how you can really customize what you want to see on a weather map on a website. And of course, in order to make all these weather maps, meteorologists have to collect weather data. Now this has been automated for the most part, but there's still lots and lots of unofficial weather stations like the one at our school here. And the National Weather Service, which is a part of NOAA, makes forecasts for our weather on a 24/7 basis. Now one of the things in this course you're going to have to be able to read is a weather station model. And this visualizes lots of different weather information in one small kind of tiny area on a weather map. And what you see here is just an example of where all the different weather pieces of information are located, and they're always located in those same spots for the most part, except for things like the wind speed and wind direction. That part does change. But for the most part, everything's in the same spot. So what you have to be able to do is learn how to read these numbers and interpret them and create them yourself. So before I move on to the next slide, one thing you'll notice is the temperature is in Fahrenheit, visibility is in miles, dew points in Fahrenheit as well. Barometric pressure is in millibars, and any kind of precipitation is in inches. Wind speed is in knots, not miles per hour. Remember, 1 knot is a little bit faster than 1 mile per hour. It stands for a nautical mile per hour. Another thing before we move on, air pressure is encoded on these weather station models, and you have to decode them, or vice versa, depending on what kind of question you're asked. And so the way I like to teach this is that if the 3-digit barometric pressure number is above 500, then what we do is we add a 9 in front of that 3-digit number, and we put a decimal just before the last number. And you'll see what I mean when we get to some of these examples. And if the number, the 3-digit barometric pressure number, is below 500, like the one in the example above there, the 196, then you add a 10 to the front. You literally put a 10 in front of the number, and you add a decimal before that last number. All right, some other things here. Present weather. You can see all the different symbols in your reference tables for present weather. And the symbol on the left-hand model over here, you can see this represents the freezing rain going on at that station model. At station D here, you can see it's raining, as it is here too. And you can even see drizzle is occurring at this station. So there's all different kinds of present weather you can identify on these maps, and we'll see quite a bunch before we're through with this topic. All right, so if we were just going to go through and identify the different variables, the different conditions at this particular weather station, we'd go through the air temperature. It's in the upper left-hand side, 74 Fahrenheit. The dew point is in the lower left-hand side at 72. And you notice they're kind of close to each other. Remember that if those numbers equal each other, it's probably precipitating, or at least it's 100% relative humidity. There could be fog, and you'll probably notice an overcast or completely 100% cloudy sky. So always keep track of those numbers. If they're far apart, then it's going to be clearer, drier weather. Visibility is sandwiched between those two numbers, and it's at 10, and that's in miles. 10 miles visible. So it's relatively clear, but that just means there's less haze in the sky. You can see farther. Present weather, I don't see any present weather at this particular one, so they're not either displaying it or there is none, so you just leave it as none. Cloud conditions, it's partly cloudy here, but we say 50% coverage because it's half shaded in the circle. Wind speed, we have a whole feather and we have a half feather at the end of the wind indicator. And so that adds up to 10 knots plus 5 knots is a 15-knot wind. Wind direction is out of the southeast. It's pointing which way the wind's coming from. And in this case, it's a little bit more south than it is east. So we could even say south-southeast. But southeast would get you an okay answer on this. Barometric pressure, 002. Remember, if it's below 500, what do you put in front of it? If you said 10, that's correct. So it would be a 10 in front and a decimal before that last number, which is 1,000.2 millibars. Pressure change and trend. In the last 3 hours, the pressure change is the middle number there, and it's gone down. You can see it's a steady downward trend with that downward angling line, and it's a negative in front of it. But because there's two numbers there, you have to stick the decimal point between those two numbers. That's the standard format. So it's a negative 3.1. It's gone down 3.1 millibars in the last 3 hours. Now, if there was only one digit there, say it was just negative 3 with a down slash, it would be 0.3. It would go down 0.3 millibars in the last 3 hours. Okay, and as far as the rainfall goes, or precipitation, half an inch, 0.5 inches in the last 6 hours. So precipitation is in 6-hour increments, updated, and the air pressure trend is 3 hours. Okay, let's try another one. Air temperature, upper left, 48 Fahrenheit. Dew point, also 48. Maybe it's raining here or something else. We'll get to that. Visibility, only 0.5 miles, half a mile, so it's much harder to see a long distance. Present weather, we have some fog going on. That's perhaps why we can't see too far, and that makes sense because the air temperature and the dew point are both 48. Cloud conditions, 100%. It's completely shaded in. Wind speed, pretty windy. We got 2 whole feathers, which is 20 knots, plus 5 knots with a half feather. 25 knots. Wind direction is out of the northwest. Barometric pressure, now it's above 500. 986 is higher than 500. So we don't put a 10 in front. We put a 9 in front and a decimal before that last number. So it should be 998.6. And yes, it is. Okay, pressure change and trend. It's gone down 13, but it's not really 13. There's 2 digits, so you got to know to put the decimal between them. So down 1.3 millibars in the last 3 hours. And there doesn't seem to be any precipitation here, no rainfall. All right, let's try one more. Air temperature, 72. Dew point, also, or close to it, 71, so they are close. Visibility, 2 miles. Present weather, we got haze. So it's somewhat moist. Cloud conditions, overcast, once again, 100% cloudy. Overcast is the term we use for that. Wind speed, we got a 1.5 feather, is 15 knots. And the wind, it looks like it's coming out of the southwest. The barometric pressure is not indicated, unknown. Pressure change and trend, unknown. But we do have a little bit of precipitation here, and that's 0.5 inches in the last 6 hours. So sometimes things are just left off of weather station models, and that's okay for our purposes here. Don't try to make something up if it doesn't exist. Okay, present weather at the cold front. So here we have a low pressure cyclone. You might recall this stuff from a few lessons ago. And you can see a cold front and a warm front. And at the cold front, you'll notice a number of these. And if you look at your present weather symbols chart or in your reference tables, you'll see that there's thunderstorms going on at the cold front, which can happen at cold fronts because of that lifting effect of that warm, moist air Remember, probably in here we have a maritime tropical air mass, and probably back here, continental polar. And as that continental polar air drives underneath the maritime tropical, that warm, moist air in front of it rises, expands, and cools to the dew point and can create these thunderstorms. Is it raining behind or in front of the warm front? And if you look at the present weather up here, you can see it's raining there and there. And it's raining, remember, either at and in front of the warm front. In front of front. And that happens at warm fronts because of the different angle of the warm, moist air rising up over the relatively cooler air in front of it. All right, let's move on. The passing of which type of front clears the sky of clouds? And you should be able to tell that just from looking at this picture here, this diagram. And you can see it's pretty cloudy everywhere except for over here. And so what front passed and then therefore made that clearing of skies? And that would be the cold front. So as that front passes, that cold, dry air moves in, and that air is sinking, compressing, and warming up and evaporating those clouds away. So we have clear skies behind it. And then we'll stop the video here, and maybe you guys can come up with any other questions you can think to ask from this picture. I'm sure there's a couple just looking at it. And another thing to mention is scale. Remember, these things are large. All right, so let's practice some weather maps here. This stuff is kind of fun. See you next time.